All right, we are going to do another trigonometric exploration today, and it's going to start with, again, creating an angle in standard position. So, same way we did it last time, we're going to intersect two objects. We're going to get y-axis, x-axis, and create point A. Point on object, B will be on the positive x-axis. That will be our initial side. Terminal side we're actually going to use by making a line through 2 points. And we're going to make A, and then we're going to put C down here in the third quadrant. All right, so there we have our angle there. What we want to do is make point D up here the same distance from A that C is. We do that by using the circle with center through point tool. And we're going to choose A for the center, C for the point on the circle, and then we're going to create a pointed intersection, intersect two objects, and click right on the intersection of the circle and the line, which will be point D. All right, over in our algebra view, here's the equation of the circle. We're going to hide that so that the circle is gone, and we see we can make angle BAD. Right up here under angle, BAD, and of course we're going to rename that, as we did last time, rename it to theta. All right, here we go. We of course now need the distance from A to D. That's under this tool here, distance or length from A to D. And we're of course going to rename that to R to be like the radius of our circle. It will also stand for velocity, which we're going to get into in just a bit. So we have angle theta. At this point, we need to evaluate the tangent of theta and the secant of theta. So we're going to do that now. There's the tangent of theta. Let's rename that to tan theta, and I'd like you to do the same for the secant of theta. You now have the tangent of theta and the secant of theta. We recall that this line here, if we did the equation and the slope, y equals mx plus b, the slope 1.24 is the same as the tangent. We explored that last time. Now we are going to make a slider so we can get a variable g for our gravity. So the slider is up here, and you're going to make a slider, and then just click in your graphics view. Let's call it g for gravity, and then we're going to let the minimum here be 0.1. We'll have a maximum of 2, and our increment will be 0.1. So we now have a slider that goes all the way from 0.1 to 2. I'm going to leave mine at 0.8 for now, and then we're going to talk about another formula. You don't have to do this, but I loaded Wikipedia and went under trajectory, and we're going to show the equation for the derivation of the equation of motion. Notice how it uses cosine theta and sine theta. The v in this case, velocity, is actually equivalent to our value, the value we have r. And here is the equation of motion. I know it's long, and I'm going to type that in and show you how we type that in. It does use x times tangent theta, y equals mx. So let's go back to our document. All right, you can type in this equation the way you see it in the input bar down here. And then I'm going to hit enter, and we should see a parabola that's actually going to show the equation of motion over time. And we get this parabola now. So based on this distance here as an initial velocity, and then this unit here being the time, would be the path of a projectile motion, given this angle of theta and this distance r to be the velocity. All right, we're almost done. We've got the equation for our parabola, and notice how that shows up. That's exactly what we had on Wikipedia for our parabola. Here comes the fun part. You're going to go to my website, and I've got a screenshot of Angry Birds. So you're going to right click, and you're going to go to copy that image, and then you're going to go right back to here, and then insert the image is under here. Insert image, you're going to go to Alt, click, and that image is going to paste in. And we can move that around, bring that right in. We can also right click on the properties of that. And why don't we go to Style and make it a bit more opaque, or a bit less opaque, more transparent, so that we can see more of our graph, get the original Angry Bird right on the point of origin, the origin of our graph, and then this is how we would pull back and sling the bird to hit the pigs and our graph. Isn't that cool? So it all depends on how far you pull down and the angle that you're at as to what kind of motion you're going to get. You can do this. You can also change gravity around, all right, depending on what the gravity is for different birds and things like that. And you're good to go. All you have to do now is put your name and a title on this. If you want to get some other screenshots, have some fun. All right?